Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on October 23, 2025, about 4 days ago. This paper introduces Real Deep Research, a generalizable pipeline for organizing and analyzing massive research corpora, and in a user study, it beat commercial large language model baselines with an average rank 1.30 and pairwise winning rates of 89.47% in natural language processing and 94.74% for foundation model output. The paper is titled Real Deep Research for AI, Robotics and Beyond, and as we will see later, the results are really impressive. It crawls major venues, applies perspective-guided reasoning and embeddings, and delivers surveys, trend maps, cross-domain links, and strong unsupervised clustering, including 84.86 accuracy on Ag News and 52.91 on 20 newsgroups. Alright, the introduction laid out the challenge and the promise. Figure 1 presents the core outputs: a clustered map of papers, perspective-guided panels with trend lines, and a simple field legend. Each dot represents a paper, and each sphere marks a topic cluster, which supports survey generation and retrieval. The callout panels illustrate example clusters with rising or falling trends. The colored bars label fields, so cross-domain links become visually obvious. Well, Figure 1 sketched the outputs. Figure 2 shows the end-to-end pipeline that collects papers, filters them, reasons over content, and projects everything into an embedding space. An overview of the graphics ties venues, filtering, and projection together so the flow stays clear. The left column lists source venues that the web crawler aggregates. The middle blocks labeled Efficient Thinking and Deep Thinking represent area filtering and perspective reasoning, which prepare text for embedding. The right scatter plot visualizes the knowledge manifold, so related papers cluster together. Alright, the previous figure mapped the pipeline. This table organizes one robotics theme into a clear taxonomy. The table presents perception and mapping, with columns for subcategory, what is covered, typical examples, and cluster identifiers that point back to embedding groups. The subcategories include multimodal sensor fusion, three-dimensional reconstruction or occupancy, and bird's eye or top view mapping. Each row states the practical goal and gives concrete examples, so a reader can jump directly to the most relevant cluster. Alright, the previous table organized a robotics theme. Table 2 presents the evaluation of survey quality across models and domains. The left column lists baselines like GPT-5, GPT-5 Thinking, GPT-5 Research, Gemini, and Gemini Thinking. The bottom row shows RDR with the best average rank at 1.30 and standout winning rates, about 89% in natural language processing, 95% for foundation model output, 91% for sensors, 84% for body, and 89% for action. These results indicate consistently stronger surveys. So, the previous table reported survey quality. Table 4 organizes the foundation model landscape into 7 categories, with subcategories, coverage notes, typical examples, and cluster links. The table acts like a roadmap, because each row states what the work tries to achieve and where to find it in the embedding space. The top section highlights model modalities and representations, spanning vision language, multimodal, and three-dimensional video. Farther down, safety alignment and ethics lists safety alignment, bias mitigation, and preference optimization. So the previous table covered foundation models. Table 5 presents a robotics domain survey that organizes 10 categories, each with subcategories, coverage notes, typical examples, and cluster links. The first block highlights perception and mapping, spanning multimodal sensor fusion, three-dimensional reconstruction, and bird's eye mapping. Mid-table sections cover manipulation and grasping, locomotion and navigation, and language-guided planning. The bottom rows emphasize safety and robustness and multi-robot or human collaboration, which signal deployment priorities. So, the previous table organized robotics topics into categories. Figure 6 presents trend lines across 30 robotics clusters from 2021 to 2025. Each mini-plot tracks paper momentum, which rises for areas like learning-driven manipulation and open-source robotics, stays steady for classic estimation and mapping, and dips for some trajectory and offline reinforcement learning threads. The shared axes make comparisons straightforward, so growth and decline become visually obvious. The visualization serves as a quick barometer for where attention is moving next. Wrapping up, 2 takeaways stand out. The Real Deep Research pipeline turns messy literatures into perspective-guided embeddings that yield clear surveys, trend maps, and retrieval, and it outperforms commercial large language model baselines in head-to-head user studies. The broader implication is actionable, cross-domain discovery for fast-moving fields beyond AI and robotics. Thanks for listening. I am Alex, signing off.